Maps on the web used to be flat, static images. Today, we expect them to be dynamic, deeply immersive spatial environments. We achieve this using a web design technique called scrollytelling. As you read text vertically down a page, the underlying code automatically commands a map to navigate horizontally alongside you. Building this system requires a basic foundation in HTML, CSS, JavaScript, and a dedicated mapping library. By linking the map directly to the user's scroll position, you remove the friction of manual navigation. Your audience has to experience the geographic context exactly as you intended. Step 1 is building a spatial storyboard. We need to mathematically link your written chapters to specific geographic locations. This data array illustrates the basic structure. You pair text directly to precise coordinates. You must also calibrate the zoom. A pinpoint works for a building, but for a wider region, you adjust coordinates to expand the camera into a broader bounding box. Once your storyboard data is organized, you can translate it into an actual HTML front-end structure. We set up a split-screen architecture. One container holds scrolling text, and a separate container holds the map. This structural layout uses a specific CSS property, either position sticky or position fixed. As the text column slides vertically, the adjacent square map container remains rigidly locked in place on the screen. Before touching JavaScript, verify this layout works. Make sure your text scrolls freely past that blank immobile map container. Establishing this strict CSS barrier is critical. It successfully isolates the mechanical scrolling of the text from the heavy lifting of the map's rendering engine. Now we inject a web GIS library, like Mapbox.gl.js, directly into that locked container. Modern mapping libraries rely on WebGL. This technology leverages your computer's graphics processor to render complex scenes smoothly in the browser. This model illustrates the performance leap. Older web maps downloaded pixelated raster images. Today, the server sends scalable vector data. Because it's raw data, the browser styles it in real time. Lines scale up dramatically and redraw instantly without losing resolution. When you initialize the map in your JavaScript, that blank container connects to the library and populates with this fully rendered vector data. Relying on this client-side vector rendering is the mathematical requirement for achieving smooth, cinematic flight between your story points. The final phase is writing the JavaScript that translates your vertical scrolling into that horizontal map movement. To do this, we use a built-in browser tool called an intersection observer. It acts as a sensor, detecting exactly when a new text chapter slides into the reader's view. When a text block intersects this line, it fires a signal, shifting the map's focus. If blocks are packed tightly, signals jam and the animation glitches. Adding CSS padding between chapters slows the trigger frequency, giving the camera time to finish its movement. When tuned correctly, the script takes over entirely. The user's reading speed drives the camera from location to location, replacing manual panning completely. By wiring these triggers together, your JavaScript elevates passive reading into an active engine that controls the visual context. This technique creates a seamless connection between a linear human story and the exploration of dynamic digital environments. Once you have the foundation, you can push the code further. Upgrading from a standard 2D map to a high-performance 3D WebGL city model only requires a few extra lines of configuration. You can pipe real-time IoT data feeds directly into those vector layers, turning a historical narrative into a live operational dashboard. When you drive the experience with a spatial narrative, the map stops being a simple embedded component. The map becomes the web page itself.